Determine the partial sum s sub 20 for the following sequence. So remember, when we write s sub 20, that means we're trying to find the sum of the first 20 terms of the sequence. So essentially that means that n is equal to 20. We want to add up 20 numbers. So first we need to establish the pattern. And in this case, you might think, what am I adding or subtracting to 1 over 30 to get 1 over 10? And then what am I adding or subtracting to 1 over 10 to get 1 over 6? But you might feel a little overwhelmed by these fractions. So one hint that I have would be to get a common denominator here, and let's rewrite all of these fractions with a common denominator. Then the pattern might be more obvious. So my common denominator is 30. So the first fraction would just stay 1 over 30. My second fraction has a denominator of 10, so if I multiply by 3, 1/10 is 3/30. My third fraction, which is 1 over 6, 1/6 is really 5/30. Then we have 7 over 30, or 7/30. And then the last fraction of 3/10 would become 9/30. So now that I have a common denominator, I think the pattern becomes much more obvious. To go from one term to the next, it looks like we are adding 2/30 each time. And that pattern repeats. If I continue adding 2/30, I'll continue to get the next term. So this tells us two things. One, it tells us that this sequence of numbers is arithmetic. And then we also know that our common difference is 2/30, which if you want to simplify, of course, that would be 1 over 15. So once we know that we have an arithmetic sequence of numbers, and we realize that we're trying to find the sum of that sequence, then we can utilize our sum formula for arithmetic sequences. So when we're adding up the terms of an arithmetic sequence, then we can have s sub n is equal to the number of terms times the first term, a sub 1, plus the last term, a sub n, all divided by 2. So in this case, we're finding the sum of the first 20 terms, so n is equal to 20. Now we can see in our sequence that our first term is 1 over 30. However, when we go to find the last term, we don't have the last term of this sequence. This would be the 20th term. So I'm going to write this as a sub 20 since I don't know it right now, and we'll leave it like this and divide by 2. And this helps me realize that I need to do some work to figure out the 20th term of the sequence before I can actually figure out the sum. So I'm going to split my work here and pause on my sum on the left side here and go to the right side and figure out how can I find the 20th term of this sequence. Well, one option would be brute force. I could just keep adding 2 over 30 repetitively and do that until I got to the 20th term. But it'd be much more efficient to go ahead and come up with a formula for this sequence of numbers. Since it's arithmetic, we know we have an arithmetic formula for any arithmetic sequence. It can be defined as a sub 1 plus n minus 1 times d. So we could go ahead and use this formula to generate a general formula for the sequence of numbers, which would be, the first term is 1/30 plus n minus 1 times my common difference. And although my common difference really is 1/15, I'm going to leave it as 2 over 30, just because I have a feeling I may need to combine like terms, and it's helpful to already have a common denominator. So now, if I'm looking for the 20th term, I can go ahead and just substitute 20 in for n. So 20 minus 1 times 2 over 30. In other words, with a little computation, I think we'll figure out the 20th term. That's going to be 19 times 2 over 30. Just be careful with your fractions. Remember, that's a 19 over 1. So we really have 1/30 plus 38/30. Now you can see why it was helpful to have the common denominator, which will give us 39/30. And of course, we could simplify that. 39/30ths, if we divide by 3, is really equivalent to 13/10. So this is the 20th term of the sequence, which I can now substitute in for a sub 20. So the sum of the first 20 terms will be found by taking 20 times 1/30th plus the 20th term. I'm going to go ahead and leave it as 39/30 since I can see I have a common denominator. So we might as well leave it. I'll divide it by 2. And at this point, you could very easily, oops, sorry you guys, I just saw that I wrote 30/30. Let's try that again. That was 39/30. I'm glad I caught that early. So from here, you could certainly go to your calculator. However, I'm going to show you how simple this computation actually turns out to be in this example. Here we could divide 2 into 20 and have 10, and then add our fractions since they already have a common denominator. So we would have the sum of 20 terms would be 10 times 1/30th plus 39/30ths is going to give us 40/30ths. And 10 divides into 30 3 times, so we end up with a sum of 40/3. And then this, of course, is my exact answer. If you were to go ahead and do your division, 40 divided by 3 would give you a sum of approximately 13.3 repeating. But I always appreciate an exact answer if we can go ahead and reach one.